We're starting to get all those panelists into place right now. Rachel Sloan from the U.S. Census Bureau will chair this session with 3 papers. So we're a little bit early, but we might as well take advantage, I guess, of the time if Peter and the others are available.
Great, thanks. Again, I'm Rachel Sloan. I'm from the Census Bureau. So we have 3 speakers today for this session. And so the first one is Peter Meyer of Statistical Classifications of Fairy Tale. So if you're ready, Peter, you can share your screen and we'll get started.
Let's see here. Okay, thanks very much. Hi, colleagues. I'm Peter Meyer, an economist at Bureau of Labor Statistics, and I'm co-authoring with Dan Gilman, an information scientist here. Many of you must know him. I've just been to his retirement party today. We were working with an interagency group on metadata, and this derives from that. We're definitely not representing the views of our agency or our offices. You'll see it's independent, speculative research. Think about the statistical classifications like the ones referred to in the previous paper, like a NAICS category for an industry. Discrete codes like that characterize industries in the United States and historically, and in many countries, there are a variety of different systems for industry with somewhat similar concepts. Likewise, for occupation, many worldwide categories for occupation, discrete classifications. We haven't heard it much at this conference, but patent offices assign technology classifications to patent submissions, patent filings, classifying them by technology. And those are also discrete, and these kinds of systems can learn from one another. Geography, there are many such category systems, very precise, and they exactly divide the world. And then there are classifications used for medical conditions and treatment. The idea here is, could there be a giant online catalogs that listed these categories and classifications together? Would that be useful? We're not short of information on classifications. There's metadata of all kinds. So at the left, there's a tremendous amount of information about the ONET occupation systems, information about the occupations themselves, and also about the system itself and mapping to and from it across its versions and years. In the middle column, IPMS at University of Minnesota is a convenient source for occupation data from census, standardized in such a way that there are some standardized occupation codes. The original occupation code is also available, and other data sets can sometimes be mapped into that system, or one can get international data on occupations there. And then the information about NAICS categories is very detailed, including crosswalk information to get between systems of NAICS. In this case, as shown at the right, that's in PDF and spreadsheet files. It's more than enough information, but it isn't a simple catalog list. For patents, I work on historic patents, and so I look at some of these categories. There are precise, detailed categories for to describe a patent filing, an application. And the reason is partly to aid people searching for patents that have been filed in the past, and partly to assign work to the specialists who know that category. Patent offices around the world do a similar thing, and they now use globally standard category systems generally. Historically, each nation had its own. So if one is trying to make a unified database over a long time series, the category systems will be differentiated in the earlier period. If there were a simple table of all these various categories accessible by a machine, by a web API, then machine learning systems like the one we just heard about would be able to grab at these classifications rapidly and systematically. It could also be human readable. That is, there could be a web page for each of the many categories and classification systems. One of our goals in the paper we've written here is that such a system be findable, accessible, interoperable, and reusable, the FAIR principles intended for scientific data. Such a site, a classification server, would encourage the sharing of ancillary tools like mapping between classifications and good practices among people using the data for different purposes. A big issue in my work has been to create longer time series by making imputations to older data so it matches newer data or vice versa. Even more common is to try to compare across countries. Can we compare US agriculture to French agriculture and Brazilian agriculture when they are putting their data in systems, maybe very accurately, but with different classifications? If we just think about this from an armchair, a system like that would want to have a table for the many classifications and differentiate among their different versions. So 2012 NAICS is different from 2017 NAICS. The entry for each one should point to its predecessor or successor or both, so that it's easy for a machine to find the whole sequence. To characterize the topic that in the classification literature, that's called a family of classifications for, let's say, industry or economic activity or occupation, attributes like time and place and the source. And there are hundreds of these classifications. So even that is not a small table. Then for each category within, like say, food manufacturing in NAICS 2017, there needs to be a link to the larger class that it's in, the classification that covers that whole period, and then to the children or the subsets, and then to predecessors and successors in previous and later years. And then ideally, to help people construct a crosswalk or do the thing a crosswalk would do, link to entries in the same table for similar categories in, let's say, the European NACE industry category system, the international ISIC one, the older SIC one, and then sophisticated cross mapping between categories actually requires more information than is in a crosswalk. More on that in a minute, but it would make sense to have a link to guidance or research on how people have done such imputations or mapping in the past. Now, these categories, even if we're just talking about industry, occupation, patent, geography, and medical, hundreds of thousands of these. There are standards for this kind of thing. Classification management systems or classification servers have linked data on classifications. I do not actually have much experience with them, but XCOS is a standard for how to publish such a classification with the necessary fields, make it available as web link data. There's a substantial earlier literature. I'm summarizing it primitively by saying we just want those certain fields because I'm thinking of a simple set of tables to start with. Collectica and ARIA have built those in, either this standard or something similar, to make software that manages classifications. Those are, I believe, not immediately open to the public, not free and open to begin with, but they are probably better systems than the ones I have seen. One of my questions in this talk is where and how can we experiment on this kind of thing to build something like XCOPS or something like these tables? And when I say we, I mean people who work at GASP, people who work on these classifications, government agencies, but also citizens and crowdsourcers and people in the international statistical agencies who already approach this problem in a way, and we want to match up with them. Schema.org looks like a good place. That's a community site, published open source with database schema, not specializing, however, in these classification systems. I'm more familiar with Wikidata and Wikipedia. And here's the kind of thing we could do there, or by replicating with the same software our own wiki. And Dan and I have done that, but it's not particularly worth showing. But just look at how Wikipedia can do these things. The English Wikipedia has an article on NAICS 21. It says that it means mining. And that is linked to a Wikidata entry where one could put a bunch of formal, precise data about NAICS 21. It has the advantage of citizen contribution and crowdsourcing. It does not distinguish between the different versions of NAICS, and it couldn't be controlled by an agency. It's public, but it would be a place one could experiment. And I think a little more realistically, making wikis of that kind and then piling this kind of data into it would make it possible to experiment and see how easy can it offer a web API? Is it realistic? Is it useful? It's possible to really write something about a category and say what it means and point to interesting data in that category. So I like the human readable aspect at the top as well as the machine readable aspect at the bottom. A crosswalk assigns a category in one system directly to a category in another system, one-to-one. But when one looks at many variables, it's often possible to see a better mapping because not all of the ones in the first category should go into that main best match. Some of them should go elsewhere. I put a surprising amount of time into that class of problems. And for example, here, in the 1960 census, lawyers and judges were not distinguished, but we can impute with some accuracy which of the observations in that combined category are lawyers and which ones are judges based on attributes that we see in later census years. That kind of imputation and a random forest can do it better. And the machine learning techniques now are better than that. So we will have very good techniques for this. And maybe a classification server can give guidance or even somehow, well, offer the source code or execute source code to do such assignments for the user. That's a little hard to envision. That's something different from what a wiki would do. But that kind of ambition becomes more thinkable if we have some kind of centralized classification server. So there's vast information about these statistical classifications. There's some services that would be aided by having catalogs of them. Auto-coding would be assisted, validation, translation between languages, interpretation in the sense of simply understanding the category you've been given. It can serve machine learning purposes. And then kind of the big problem is mapping between classification systems because there are whole sets of comparisons we don't do because the classification systems aren't supporting us. They're too distinct. And there's good reasons they are distinct, but we want to overcome that. And then beyond that, there's a science of classifications. That is, when there's technology change, a wave of patents arrives, there are new industries and occupations. That's an interesting subject in which the classification systems themselves are changing. And we don't really know the structure and time order of that. But it would become straightforward to see it if we had all these combined data on classifications. An issue is that the supply and demand for this kind of precise classification metadata is thinly spread, so it has to be worked on a large scale with a lot of cooperation. Data.gov, as an example, might be an ideal place to host such information, but it shouldn't be completely official. It's partly experimental. And it's to be internationally cooperative. So it isn't up to one government to provide it. I think cooperating on some other set of platforms like schema.org, Wikidata, or wikis that we invent is probably the way to go. And I think a lot of people in this audience know more than I do. So I'd like to use the Q&A for you to look at my questions and give me your answers. Thank you.
Great, thank you, Peter. I'm looking in the Q&A. I don't see any questions for you right now, but we should have more time for questions at the end. Just reminder to everyone, you can put in a question in the Q&A feature and just make sure you put who the question is addressed to. So for now, we'll move on to the next speaker, Alexander Young from University of New Hampshire.
Hello, good afternoon. I'm looking forward to sharing my screen.
I'm looking forward to
is.
seeing it.
Great. Be here. Go into presenter mode.
Got it.
All right. Thank you. My name's Alex Young. I am a research scientist at the University of New Hampshire. And for the past 3 years, I've been working with the information management team of the Urban Forest Inventory and Analysis program. I'll be presenting work today that was developed as part of the USDA Data Science Training Program. It just wrapped up. I was part of the Advanced R track, and I'll be showing a Quarto document after this PowerPoint. So I did say urban forest inventory. You might think of the Forest Service and think of trees in the woods and the forest land that are represented on the left. But in 2014, in an effort to better document the health and condition of trees that are where a majority of the people live in urban areas, the Forest Service began an urban forest inventory following much of the same strategic inventory methodology. We are actively collecting data in 40 cities and also in more than 20 states as part of a statewide urban area inventory. And what you'll see here in purple there are 20 cities that have publicly available urban forest inventory data that you could download, and also online tools to explore should you want to. But what does it look like? So I've done forest inventory, I've done urban forest inventory, and the way it goes is you're on public or private land. This orange pole here is being used to get an accurate measurement of tree height, but crews record trunk diameter, crown characteristics, and other things that help keep track of the forest. So my objectives for the talk today are to talk about combining boots on the ground information with also remote sensing data, to talk about the work I did to develop a pipeline that would work for any urban FIA project, and also to potentially create a spatially continuous data output that would avoid using any private or sensitive data and only use publicly available information. So with that, I'll transition to this Quarto document. So this was made in R and a Quarto document to make an HTML file. And we're seeing a report made for Baltimore, Maryland. We use a systematic grid-based design for our sampling points. And so there's roughly one plot per hexagon across the city of Baltimore. And you'll see here, this is the National Land Cover Database land cover categories. I've grouped them into broad categories, less than 50% impervious or greater than 50% impervious, just for cross-city comparison. But you can see what that breakdown looks like on the left. So for each one plot, and you saw an image of this on the PowerPoint, each plot has about the same footprint as a 30-meter pixel. It's a little bit smaller, but every tree in that 30-meter pixel is measured, and we'll be working with a couple of attributes. So the maximum height of a tree on the plot, we're looking at the field measured tree cover on the plot, and then also the land cover group. And it might not be uncommon knowledge, but the taller trees usually are the larger trees and usually have the most leaf area. And conversely, the trees that aren't so tall don't have much leaf area. And so by capturing both height and cover, I was wondering, just using the plot information, how well could we do at predicting the leaf area, the cumulative leaf area on the plot, and it looks like pretty darn well. Across a couple cities, I'm seeing an R squared of ranging from like 0.8, 0.9, 0.7, but this is all the plot-based stuff. Let's bring in the remote sensing information. So there were 2, maybe 3 remote sensing data products that I used for this project. One is a 10-meter pixel resolution canopy height data product, and I upsampled this to 30 meters so that it would play nicely with both the sample size of the measurement area of the plot, but also 30 meters plays well with the tree cover from Landsat. So I used the V4 tree cover data set, and both of these were accessed using Google Earth Engine and exported to my computer locally. As I mentioned before, the plot is about the size of a 30-meter pixel, and so I'm using that synergy to see how well the 2 overlay on top of each other. So in purple and teal is the combination of the height and the tree cover for each pixel. And the really nice thing is that you can see with the points of field measured tree height and tree cover, there's a broad overlap where it seems like both the remote sensing information and the field collected data are broadly capturing this relationship between tree height and crown cover in a way that I was able to produce a multiple linear regression model. And for a given height and a given tree cover, we can actually predict what the leaf area would be for any given pixel. And so I show that here as the city of Baltimore and the predicted leaf area. And so this has an advantage of not just giving a broad estimate, but if you wanted to zoom in to your corner of the world and look at the leaf area characteristics, this data modality would allow for that to happen. And I'll close by just saying one of the neat things that we could maybe think about doing with this type of information is bringing in this census data. So using the Tidy Census R package, I was able to summarize the leaf area estimates by census block group. And you can maybe look at a per capita leaf area estimate, whereas before with only one plot per hexagon, it's kind of coarse, and this provides the spatially continuous information to have different insights. So thank you so much. Happy to take questions. And if you have any ideas or concerns, happy to hear them. Thank you.
Great, thanks. It looks like you do have a question. How do you treat pine tree lots in Georgia?
Oh, good question. Yeah, pine trees have needles, and I think the same general relationship. There are leaf area equations to get the leaf area for conifer trees. Unfortunately, I don't think there is a urban forest inventory in Georgia, and I meant to mention the value of being in the field and collecting these relationships of height and tree cover is that it's like a locally representative estimate, and I'm not sure how well that would perform when you take it into a different region. But I'm happy to talk offline if I didn't answer this question well.
Great, thank you. That's the only question for you I see right now. So our last speaker is Sagnik Chakravarti of University of Maryland. I don't see them in the chat, so they may not actually be here today.
Yeah, I haven't been able to, I've tried to contact them and they haven't reached out. So if
Okay.
you want, you can check to see if anybody has other questions or whatever. But
Okay.
yeah, thank you.
Okay, so Peter, it looks like in the Q&A you had some questions that you answered. Did either you, Peter or Alexander, since we have a little bit more time, I know the sessions you prepared today had to be very short. If there's maybe any other information you wanted to tell us or anything you wanted to expand on for just a couple minutes that didn't make it into the PowerPoint, looks like we have a little time. And for anyone else who still has some questions, feel free to use the Q&A.
Well, it was suggested I look at a particular database of patents from chemical abstract services, and I am interested in how they standardize over time and what kind of metadata system they use. I guess I would have liked to add the patent office has for 110 years had a devoted classification division where they think about the question of how to divide or reorganize the classifications, which I think is mainly meant to channel their own workflow better. And I would like to learn from that for the benefit of those of us who work on occupation and industry. I welcome this tip and anybody else pointing me to information of that kind.
Great. And Alex, there's a question for you. Do you think that remote sensing could be a substitute or fix issues with non-response bias on difficulty accessing privately owned plots?
Oh, good question. Or yeah, great question. I think it could be part of the part of a way around it, particularly if there are biases in the private land not having the access approved, and we can still measure the height of the trees on that land, and using the plots that we do have information on, imputing the value, I think would help. Yes. Might help. I'm not sure how much, but I think there have been some fantastic talks during this conference about imputing values and other methods of handling non-response. I also want to highlight this was a pretty basic approach. It's only 2 attributes, the height and the tree cover, and there very well may be more information like the spectral information of the RGB or infrared regions that might give more information about the type of tree underneath that tree cover. Thank you.
Okay, and another question for Alexander. What efforts are underway to encourage more cities to do UFI? Because the importance of tree cover came up as important to cooling during heat waves.
Oh, absolutely. And that was part of the impetus for modeling leaf area across the city, is better representing not just do you have a tree, yes or no tree canopy cover, but how much leaf area is available to provide that cooling. I think that increased outreach could be a really strong avenue to promote other cities to be interested in a statewide inventory. And I think that it's a ripe moment to talk about heat waves, given the temperatures on the East Coast right now.
Great. Well, I don't see any more questions in the Q&A chat. So thank you both, Peter and Alexander, for those presentations. They were both really interesting. And thanks for everyone for being in the session and submitting questions. I guess we can then turn it over to the next paper session.
Thank you, Rachel. I'm going to